Arduino and ESP32 can look like competitors, but in robotics they are better understood as different tools. Arduino favors simple, reliable hardware control. ESP32 shines when a project needs wireless features and more computing power. The real skill is knowing which tool fits the job. So far, you've built a strong robotics foundation, sensing with different inputs, making decisions in code, driving motors and servos, and connecting projects through Bluetooth, Wi-Fi, and IoT dashboards. Now we shift from building smart ESP32 systems to choosing the right controller for the task. The key question is simple. When do advanced features matter, and when is reliable Arduino control the better fit? ESP32 gave you power and connectivity. Arduino adds something just as important: clean, dependable hardware control. In robotics, you repeatedly read sensors, make decisions, and drive outputs. Working with Arduino helps turn those patterns into strong habits, using components you'll see in many projects. Arduino's biggest strength is that it lowers the barrier to electronics. You can connect a sensor, write simple code, and quickly see a real output. It works well for basic control tasks like lights, buzzers, servos, and motors. And because so many people use it, examples and help are easy to find. That makes Arduino excellent for learning by building. ESP32 becomes especially valuable when a project needs communication, speed, or internet access. Built-in Wi-Fi supports web control, cloud dashboards, and remote monitoring. Bluetooth makes phone-controlled robots much easier to build. Compared with many beginner Arduino boards, ESP32 also has more processing power and memory, so it can support smarter connected robotics projects with fewer extra parts. Think of Arduino and ESP32 as tools with different strengths. Arduino is often the easier starting point, with simple wiring, many beginner examples, and 5-volt logic that matches many classroom components. ESP32 is stronger for connected projects because Wi-Fi and Bluetooth are built in, and it runs faster. The trade-off is that ESP32 usually uses 3.3-volt logic, so some sensors or modules need extra care. Choose Arduino for straightforward control practice. Choose ESP32 when the project needs networking, mobile control, or smart device behavior. Choosing a board is like choosing transportation. For a short, simple path, a bicycle may be easier than a car. In the same way, Arduino is often the better choice for LEDs, buttons, buzzers, sensors, and basic motor control. It keeps the wiring and code easier to understand. But when a project needs Wi-Fi, Bluetooth, online data, or phone control, the ESP32 earns its extra complexity. The key engineering habit is not choosing the most powerful board. It is choosing the simplest board that solves the problem well. Voltage is one of the biggest practical differences between an Arduino Uno and an ESP32. Many Uno projects use 5-volt logic, which is forgiving with beginner sensors and modules. The ESP32 usually expects 3.3 volts on its input pins. Feeding it a 5-volt signal can permanently damage the chip, even if the board still powers on. Before connecting any sensor, check its output voltage, not just its power voltage. And when devices communicate with each other, connect their grounds together so they share the same reference. Both boards can read sensors and control outputs, but they feel different when you start wiring. The Arduino Uno is very predictable. Digital pins handle buttons, LEDs, and control signals. Analog inputs read changing voltages, and power and ground are easy to identify. That clarity helps beginners avoid mistakes. ESP32 gives you more flexibility and usually more capability, including wireless projects and advanced peripherals. The trade-off is pin selection. Some ESP32 pins affect booting or have special hardware roles, so you need to check before connecting. Arduino shines when the job is direct, repeatable hardware control. Think of it as a steady coordinator. Read a button or sensor, decide what should happen, then drive an LED, servo, or motor. For motors, the important habit is to use a motor driver and separate power, while keeping a shared ground with the Arduino. Reliability usually comes from simplicity. Test sensor readings first. Confirm voltages. Move one actuator at a time. Then keep the loop logic clear, so each part behaves predictably before the whole system works together. A good board choice often starts with one question. Does the robot need wireless communication? If the answer is no, Arduino is usually the cleaner choice. It handles sensors, motors, and direct control with fewer setup steps and fewer things to debug. If the robot needs a phone app, web dashboard, cloud data, or remote control, ESP32 becomes much more attractive because Wi-Fi and Bluetooth are built in. The trade-off is complexity. Wireless control is powerful, but networks, pairing, and connection failures become part of the project from day one. Choose the controller by starting with the project, not the board. If the goal is a reaction game, basic robot, sensor practice, or servo arm, Arduino is usually the simpler choice. It is beginner-friendly and works well with many classroom parts. Choose ESP32 when the project needs wireless communication, such as a Wi-Fi robot, Bluetooth car, IoT plant monitor, or alert dashboard. Before deciding, check voltage, available pins, sensor compatibility, and power supply. Strong builders can explain why their hardware fits the job. Blink is the Arduino Hello World. Start by connecting the board with USB so the computer can power it and communicate with it. In the Arduino IDE, choose the exact board model and the correct port. Those two settings tell the software where to send the program. Then upload the Blink sketch, which turns the built-in LED on, waits, turns it off, and waits again. If the LED flashes, you have confirmed the full loop. Hardware, cable, driver, IDE settings, code, and upload are all working. After Blink, the next big pattern is sensing. A sensor changes something in the real world into a number the Arduino can read, often with analog read on a pin like A0. The code stores that number in a variable, such as sensor value. Then it asks a question. Is this value above the threshold? If yes, turn something on. If no, leave it off, or do something different. The output might be an LED today, but the same logic can drive a buzzer, servo, display, or motor later. Engineers do not ask which board is always best. They ask what the project needs. Arduino is the easy, reliable choice for sensors, motors, and local control. ESP32 adds power, Wi-Fi, Bluetooth, and remote features. Next, you will apply these choices in real builds: a reaction timer, a color sorting arm, and a maze robot.